This is a quick and dirty video helping them fill out table 2. So the information down here is table 2, and this is from table 1. All the numbers here are made up. This is just as a sample of how to run through it. So recognize that that is the charge just before putting the cup, just before putting the PVC pipe into the aluminum cup, and that's the charge afterwards. So this is the effect of the charge of the PVC pipe. So ultimately, the charge on the PVC pipe, what is labeled as Q1, I believe, is going to be that minus that. So we can, so equals that minus that. The styrofoam cup, again, this is before you put it into the aluminum cup, and this is afterwards. And so this is the effect of the styrofoam. And so the charge would be basically, what is the change from here to here? And change is always final minus initial. So it's going to be the negative 22.89 minus the negative 1.56. And equals that minus. All right, the angle difference, you would preferably look at the chart. Angle difference. It is basically where the angle ended up compared to where it started. So it's just the difference between those two values right there, the 94.1 and the 89.1. And so there we go. All right, phi is the complement of theta as shown on the diagram on the first page. So this would be ultimately equals 90 minus that. The distance the styrofoam deflects, so originally the styrofoam's hanging down like this, and then it gets pushed out that far. We know a 5-degree angle, that's the angle difference. And we know the length of it. So coming back over here, I know the height of the fulcrum, right there. I know the initial height of the mass of the styrofoam. And so the length of the fulcrum would be the difference between those. And so I'm going to just put that out here. So the length equals, and then that minus that. And again, hit the wrong button. All right, so that is the length of it. So basically the distance the styrofoam deflects, how far does it go this way? Well, it's since I know this angle up here, that's the 5-degree angle, and the angle in that corner down there is the 85-degree angle. I'm either doing that length, the 0.577, times the sine of 5 degrees or times the cosine of 85 degrees, one or the other, and that would be the distance the styrofoam deflects. And so I'm going to put this down while I type that in. Nope, wrong one. And so that is, so it deflected about 5 centimeters. And the distance between the objects, well, you have the initial distance, you have where the PVC pipe is, which is at 0.204. Oops, sorry. PVC pipe at 0.165. You have the initial position of the styrofoam, so you have that difference plus the amount that the styrofoam deflected. So this number here equals how far it weighs if the styrofoam did not move, plus the amount that it actually did move. And so that's how you fill out table 2.